In 1964, researchers cut down a living tree in Nevada. When its trunk was opened, the National Park Service says they counted 4,862 rings. The tree may have been close to 4,900 years old. Science had found one of the oldest living trees ever measured. After killing it, its stump is still there. The tree is now called Prometheus, but it is only the first problem in this story. Hundreds of kilometers away, an even older named Bristlecone is still alive. The strongest reproducible evidence places it at more than 4,150 years. The Forest Service will tell you its name, Methuselah, but not which tree it is. Then there is a third tree, an unnamed living bristlecone once reported at more than 5,000 years old. That would have changed the record again. But when researchers tried to confirm the claim, the dated core could not be located. A specialist old tree database removed the entry. One ancient tree was cut open, one is deliberately hidden. One slipped out of the scientific record when its evidence disappeared. So the mystery is larger than longevity. What does it take to prove that a tree has lived for 5 millennia, and what can be lost while obtaining that proof? To answer that, we have to begin with a piece of wood no wider than a pencil. To age a living tree without cutting it down, a researcher can use an increment borer, a narrow hollow tool that removes a cylinder of wood. Under magnification, the core becomes a line of annual growth. Wide rings, narrow rings, damaged rings, patterns formed as the tree responded to particular years. Counting is only the beginning. A core may miss the center. The oldest wood may have eroded away. Growth can become so slow that a year is difficult to see. Miss the center, overlook an extremely narrow ring or lose the original sample, and an extraordinary age can become difficult or impossible to reproduce. It was the missing sample, not proof that the reported tree was young, that removed the unnamed candidate from the record. So dendrochronologists compare ring patterns among different samples. Shared sequences of narrow and wide years can be cross-dated, like matching a long and irregular barcode. The age is therefore not merely a claim about a tree. It is a claim about a sample, a method, and whether another researcher can follow the evidence. Methuselah survives that test. A specialist database lists its age at roughly 4,150 years and marks it as cross-dated. A genome study published in 2026 gives Methuselah's age as 4,157 years, calculated to the year 2025, a refinement of the historic estimate, not a new drilling or a new core. The exact number should still be handled carefully, but the scale is real. Think about what that scale contains. The tree began growing before written Greek history, before Rome, before most languages spoken today had taken their present form. It did not watch those civilizations in any human sense. There is no memory stored in its trunk like a diary. Yet every surviving ring is a physical response to one season in the same mountain landscape. The tree is not a witness with a story to tell. It is a continuity that human history rarely allows us to encounter. How can one organism remain alive across almost 50 centuries? The tempting answer is that bristlecones possess a secret of immortality. They do not. Their longevity appears to be built from several ordinary advantages, each pushed to an extraordinary extreme. High in the Great Basin ranges, the growing season is short. The air is cold and dry, wind strips moisture from exposed slopes. The pale, rocky ground can support little vegetation. These conditions do not reward fast growth. A bristlecone may add only a thin layer of wood in a difficult year. But sparse ground also means fewer competitors and less continuous fuel for fire. Slow growth produces dense tissue. Resin-related defenses and unusually durable wood can resist decay and make life difficult for some insects. The landscape that limits the tree also removes some of the forces that would otherwise end it. That trade is visible in the grove. On better soil, other conifers can grow faster and eventually crowd the bristlecones. On the most exposed pale rock, competition thins out. A site that looks hostile from a human perspective may offer a different kind of stability. Less shade, less fuel, and fewer rapid changes in the plant community. The bristlecone isn't fighting the mountain and winning. It's moving at the speed the mountain allows, and that slow economy is only one part of its survival. Even the needles reject our usual sense of a yearly cycle. Bristlecone needles can remain functional for many years, instead of being replaced as an entire annual set. Resources are held and reused, rather than rebuilt from scratch each season. Nothing here is failure-proof. It is simply an economy that never has to spend everything at once. Even then, the whole tree does not need to survive in perfect condition. On very old bristlecones, sections of cambium, the living tissue that produces new wood and bark, can die. Other strips remain active. A narrow band of living bark may continue to connect functioning roots with part of the crown, while dead wood beside it is polished by centuries of ice and wind. This is why an ancient bristlecone can look half-ruined and still carry green needles. That dead surface isn't hiding anything. It's a record of territory the tree has already given up, while the rest of it keeps going. But there is no simple diagram hidden inside every trunk. A photograph cannot tell us the exact route water takes through unseen tissue, and survival by living strips is not invulnerability. Recent research has documented bristlecone mortality associated with drought stress and bark beetle pressure. 5,000 years of persistence is not a guarantee about the next century. But if a tree can surrender much of its visible trunk and keep going, what finally defeats it? Today, drought stress and beetle pressure are part of that answer. In 1964, the danger came from a human decision. And now we can return to the question the opening left unresolved. Graduate researcher Donald Currey was studying bristlecones near Wheeler Peak. The Forest Service, which administered the land, authorized the cutting. The result was the cross-section introduced at the beginning. Thousands of rings and a living archive that could never be restored. Official accounts do not settle every detail of why a complete cross-section was chosen. Later versions often supply a broken drill, a moment of necessity, or a simple accident. The available evidence does not allow us to turn those versions into motive. The number was no longer the troubling part. The unanswered question was why a living tree had to become a cross-section at all. What remains is the stump. Prometheus became famous not because science discovered that it could survive, but because science discovered its age after ending its life. That sentence is easy to use as an indictment. It is harder and more useful to sit with the contradiction. The cutting was authorized research conducted under the standards of its time. The rings helped demonstrate that extremely old bristlecones existed in the eastern Great Basin. Yet the living archive could never be restored. Its loss did not, as far as the evidence shows, directly create a national park or a federal protection law. But it became a lasting conservation warning, a record of how scientific ethics can change after the consequence is visible. Prometheus also complicates the language of records. For years it was described as the oldest known non-clonal organism. Methuselah has continued aging as a living tree. Other ancient plants survive as clonal genets, one genetic organism whose individual stems are replaced over time. Some are estimated to be much older than any living bristlecone stem. Those ages are not fake. They answer a different question. A bristlecone core can cross-date the continuous wood of one seed origin tree. A clonal colony may preserve one genetic individual while its visible modules come and go. Ancient deadwood can extend a chronology across even more years, but it is no longer a living organism. There is no honest single leaderboard until we decide what exactly is being measured. For Methuselah, protection adds another category of evidence, information that should not be made more precise. The Forest Service does not identify which tree in the grove is Methuselah. Its materials cite the risk of vandalism and heavy foot traffic. The surrounding ancient pine area also uses enforceable restrictions on removing bristlecone material, camping, fires, and access at certain times. We found no public study that measures exactly how much damage secrecy has prevented. We cannot say that anonymity guarantees survival, but the logic is not difficult to understand. A famous location can become a destination. A destination concentrates footsteps. Around a tree that grows almost imperceptibly, even small pressures can accumulate for decades. So this story ends with an absence. There will be no map pin for Methuselah here, no comparison of leaked photographs, no attempt to identify one trunk among its neighbors. Prometheus survives as exposed rings and a stump, the evidence made completely visible. Methuselah survives partly because one piece of evidence remains deliberately incomplete. The oldest named tree we can verify is still growing somewhere in that grove. Save this story, subscribe for the next one, and until next time, let one ancient tree keep its address.